Welcome once again to UKSing Maths. In this lecture, I am going to discuss why do we need complex numbers. This is one of the most important questions, that why do we need complex numbers. The analogy in logic is same as why do we need natural numbers, whole numbers, integers, rational numbers, irrational numbers, real numbers, etc. The answer is very simple. Necessity is the mother of invention. We are listening this proverb from a quite long time. It is very right. So when you are in a scarcity of something, you give more efforts to come out of that scarcity. You try to find the solution of that problem. Means a thrust arises in you to find the solution of that problem. Means a need or a problem encourages creative efforts to meet that need or solve that problem. Means inventiveness and ingenuity are stimulated by the difficulty. This is how invention works. The analogy is same over here. Let us go to our ancestors. I am talking about a quite long back when the human civilization started blossoming. At that time, our ancestors needed some sort of numbers in order to lessen the problems faced in their daily life, in the discourses of life, such as counting the numbers in hunting and all. So they invented counting numbers, which we also called as natural numbers. So necessity started from there. Subsequently, need for other number system was felt and other number systems were invented. So here I am talking about mathematics. So let us see why mathematicians needed numbers. There are many reasons, but let us have a look on this simple reason why mathematicians needed numbers. Mathematicians needed number to solve many polynomial equations, because many of our daily life problems are basically converted into a mathematical problem, and that mathematical problem is solved by some or the other way to find the solution of this problem. And this is how our mathematics works. Now let us have a look on these simple equations to understand why we needed complex number system. First, look at this monomial equation x plus 5 equal to 5. If I ask find the solution of this equation, you will say x equal to 0 is a solution of this equation. But having counting number or natural number at our disposal is not going to solve this equation, not going to supply the solution of this equation. So we needed some broader number system. So we combined natural number system along with 0 and gave a name whole number. So whole number system is a number system that consists of all natural number along with 0. Now let us have a look on this next equation, 2x plus 5 equal to 1. If I ask find the solution of this equation, then you will say x equal to minus 2 is a solution of this equation. But having whole number at our disposal is not going to supply the solution of this equation, because minus 2 is nowhere found in the whole number system. So we needed some more broader number system. So we invented integer. Integers consist of all natural numbers along with 0 and negatives of this natural number. And now let us have a look on the equation 3x minus 1 equal to 4. If I ask find the solution of this equation, you will say x equal to 5 by 3 is a solution of this equation. But having integer number system at our disposal is not going to supply the solutions of this equation, because 5 by 3 is nowhere found in the integers. So we needed some more broader number system, and we invented a rational number system. You might have studied about rational numbers in your previous classes. A number of the form p by q, where p and q are integers and q not equal to 0 is known as rational number. Now let us have a look on this next equation, x square equal to 3. If I ask what is the solution of this equation, then you will say x equal to plus minus a square root of 3 is the solution of this quadratic equation. But having rational number at our disposal is not going to supply solution of this equation, because number of the form plus minus under root 3 is nowhere found in the rational numbers. So we needed some different number system, and we invented irrational number system which could supply the solution of this equation. So irrational numbers are some different type of fellow. It has different type of characteristics and nature. So this irrational number system is a completely different type of number system. So what mathematicians did, they combined rational numbers and irrational numbers and gave a name to real numbers. So real number system consists of both rational numbers and irrational numbers. Now let us have a look on these two quadratic equations. X square minus 10x plus 40 equal to 0 and y square plus 25 equal to 0. If I ask to find the solutions of these equations, then after solving you will find that x equal to 5 plus minus square root of minus 15 and y equal to plus minus square root of minus 25 are the solutions of these equations. But if visualize carefully, you will find that these values of x and y does not found in the real number system, because in real number system nowhere the square root of a negative number is defined. Means our real number system fails to find the solutions of the equations of type. Thus comes a need to find a more broader number system which is known as complex number system, so as to include the solutions of such type of equations. Actually, an Italian mathematician named Girolamo Cardano first conceived the idea of such type of numbers. He wrote a book, Ars Magna, means the great art, in 1545 AD, in which he posed a problem to divide 10 in two parts such that the product is 40. Means if you translate this in mathematical problem, you can say x plus y equal to 10 and x into y equal to 40. Find x and y. You can also transform the same problem by eliminating one of these variables to give a quadratic equation of the type x square minus 10x plus 40 equal to 0, and you have to solve this equation. We have already seen the solution of this equation in the first equation. It comes out to be x equal to 5 plus minus a square root of minus 15, and this type of number is nowhere found in the real number system. So Girolamo Cardano was the first person who conceived the idea about the existence of numbers what are now called as imaginary numbers or complex numbers. But his understanding was in a very rudimentary stage, because he didn't understand the properties of such type of numbers. Thus we have visualized that the extension of the concept of numbers from real numbers to complex numbers have enabled us to solve many polynomial equations. The complex number system is one of the largest number system, and all other number system are inherent within it. Actually, mathematicians define different type of concepts when they face problems in the mathematical structures and all. This real number system is also further expanded by adding two things, plus infinity and minus infinity, and that number system is known as extended real number system. Extended real number system consists of both minus infinity and plus infinity. Actually, this infinity is not a number, it is an imagination, as large as you please, as large as you think. So plus infinity means as large as you think, minus infinity means as small as you think. Similarly, while dealing with the Riemann sphere and stereographic projections and all, mathematicians defined a concept, point at infinity. So they added infinity to this complex number set and they called it extended complex numbers, set of extended complex number, and the plane in which that complex number is represented is known as extended complex plane. Thank you for watching UKSing Maths. If you wish, you can like and subscribe UKSing Maths, our YouTube channel, to stay connected with us. You are free to comment on the content of the articles and suggest any improvement if any. Your suggestions are always welcome and highly appreciated. Thank you.